Thank you. Good afternoon, everyone. So today I will give a talk about how to build a robust ETL pipeline using the Spark SQL. Okay. So I'm from Databricks. Databricks was founded by the team who created Apache Spark. So our mission is to make big data simple, and we provide a unified analytics platform. Let me introduce myself. I'm Apache Spark committer. I work for Databricks. I got my PhD from the University of Florida. And previously, I was an IBM master inventor, worked for the curate, GDPS, and SDC. So my interest is on the Spark SQL, database replication, and the data integration. So this is the plan of today's talk. First, we need to define and to explain what is ETL pipeline, and why it is hard, and how to solve the ETL problems using Spark SQL. We also explain some existing features and some new features that are only available in 2.2 release. And at the end of this talk, I will show our plan about the Spark 2.3. Especially about the performance. And the last talk, I just mentioned the performance issues about the Apache Spark UDF. So I will also cover that at the end. So what's our plan? So first, what is the data pipeline? So we can view it as a sequence of transformation on the data. So source data could be structured, unstructured, semi-structured. And the source and the destination normally are in the different storage system. So the output data normally is integrated, structured, and curated. And after the data pipeline, the data is clean, is ready for use. So let's see this example. We read the data from the Kafka, from log, and do some transformation and put it in the cloud warehouse. We can store it back to the database and for some OLTP workloads. We also can directly query the data or do some aggregation and send it to the OLAP applications. We also can write it back to the Kafka, to the log, for some streaming EC application or for even another data pipeline. We also can use the data to train our machine learning model and also apply the model to the data back. So this is the typical data pipeline. Normally, ETL is just a first step of your data pipeline. And ETL represents extract, transform, and load. So the target is to clean and curate your data. The source could be one, could be multiple. And based on your business logics, based on your data, you need to transform, clean the data, and then we load back to the destination. Okay, this is a very simple example how users use Spark SQL to do the ETL. So we read a JSON file, and then do some transformation, filter, aggregation, and then write it back. Very, very simple, right? This is from 1 to 1. This is from 2 to 1. So we read the CSV file, and then we read the JDBC table. After that, we join them together, and use name as a join key, do a full auto join. And then we filter out some illegal rows, and then we write to the a table. And the format is a packet, and this is a catalog table. Later, you can query this table using no matter data frame API or the SQL API. Also very simple. But why? With many people complain, okay, ETL queries are so hard. It looks very simple. Let's look at why. First, the data could be from different sources, multiple sources. The formats, the data source, you have to support. So this might be a difficult problem for the traditional ETL products. However, for the Spark, I will explain why it is not a problem. And then we could have an issue about schema. So the users define the schema, but the data might not follow the schema. And if you get the data from the different sources, their schema might not match. Even for the single column, you could have a different way to represent the same things, like daytime, how many ways we can represent, right? Even the standard has 3 or 4 ways at least. And the file could be corrupted. Even the file is not corrupted, it could contain some corrupted records you cannot pass. So we cannot stop the ETL pipeline because of that. And scalability. In the age of big data, single machine ETL software does not work. And you cannot, people always complain it's too slow. And even they just need to get a subset to do the ETL. And the schema is not static. Maybe after a few days, you upgrade your application, you upgrade your system, the schema is changed. And we also hear more requirements. They want a continuous ETL. So, yeah, how to solve it in the Spark SQL? That's a problem. But it also means, okay, ETL is hard, but it also means ETL is very important. Nobody wants to deal with the complex data, want to clean the data. They just want to use the data. Okay? Why? So this part, I need to convince you why the Spark SQL is a perfect platform for the ETL pipeline. Let's see what's Spark SQL. Our Spark SQL provides a flexible API. We provide a SQL API, the set API, different API. They are high-level, user-friendly APIs. And we support many data sources. Here we just list a few of them, but we have more, actually. And we also have a built-in support for the structured streaming. I believe everyone already listened the talk by the Michael about how amazing our structured streaming works. So internally, we also have a state-of-art catalyst optimizer and a Tungsten execution engine. So all of them make it great to very fit to build the ETL pipeline. Okay, let's talk one by one. Oh, sorry. So first, about the source. So we support many data sources. In Spark SQL, we have 8 built-in data sources: JSON, CSV, text, Hive, Parquet, ORC, JDBC, Kafka. And we also have many third-party data source connectors. So you can access this link and download the connectors. For example, Passenger, MongoDB, HBase, Avro. If you cannot find the data source, you also can define or customize by yourself. So you can access this link, this YouTube video. It will explain how to define, how to customize, write your own connector to access your data source. It's very simple. And the second issue is the schema. First, this example about the JSON files. Each record have the first record is A, B, C, but the second record is E, C, B, but the last record is AD. How many columns we have? This is just 3 rows. But if we have, for example, 1 GB, so it's almost impossible for human to find it. So we can do it. It's very simple. We just call the data frame reader APIs, the set files, we will infer the schema for you. See, this is A, B, C, D, E. All of them are long type. Let's make it complex. The type could be different. Right? C could be double. And the A in the first row is an integer, but the last row is a string. We will infer the type for you. We print the schema, we'll see A becomes a string, C becomes a double. Okay? And maybe some of them you don't care. So you can define your own schema, pass it to our data reader API. Here we add a column A, column B. You specify the data type. Okay, after that, it returns just 2 columns. And see, in the second row, that does not exist the A, so we just fill that now automatically. But this API still looks too complex. We don't like. So let's see. Okay, it becomes more simpler. You can specify your schema using DDL format. Now, same result. Let's see how to handle the corruption. Your file could be corrupted. Your records could be corrupted. Maybe some of you hit these exceptions. You might not know what happened and how to deal with it. I saw it multiple times in the mailing list. Actually, it is caused by the corrupt files. And how to handle it? You just need to specify, tell us, okay, you want to ignore the corrupt files, set it to true. This is the session scoped SQL configuration. Then we will skip, we will continue. For the corrupted records, we provide 3 different formats: permissive, job form, fail fast. Let's see how to use it. You can see the second record, it is corrupted. Then if you specify use a permissive mode and tell us, okay, if you specify permissive mode, we will put your corrupted records in the corrupted records. You can change the column name. For this read, you can just add one more option, column name of corrupted records. You also can change the default one. You don't need to specify that for JSON. When we infer the schema, we'll put it, as long as you use a permissive mode. The job malformed pass mode will job the corrupted records directly. So this is the result. And for the fail fast, we just stop when we hit the first corrupt records. CSV is same. The last row we use fail fast, we hit. But the error method could be different. It depends on your versions of Spark. For the permissions, for CSV, when we infer the schema, we are not directly put the corrupted records. But you still can, okay, let's look at. You can see the columns, C0, C2, C1, but maybe that's not what you want. The first row, you want make it column names. Okay, you can just specify another mode. Okay, say header to true, then we will use specified column names. And if you want to see the corrupted records, you can define your schema and pass it, and we will return. You can see the last row, the corrupted column contains the values. Of course, we also have a job malform. The last row, corrupted, job. So In Databricks Runtime 3.0, we provide another option. So it combines job form and exception files. So that means it enables you to run multi-phases data cleaning. So you can specify the exception files. In the exception files, we record the time, the data, and the reason. So no need for actual column, and yeah. We also support the multi-line JSON and CSV since 2.2. Before, when we parse the JSON and the CSV, only one line per record. Otherwise, if your records cross multi-lines, we'll treat it as corrupted records. And you can enable that. Maybe some of you, the table could have a next complex structure like array, map, structures in your table. This example. So the column values is array. It contains long type elements. So most of users to clean this data, they use a UDF. Maybe you also already listened to the previous talk about, okay, we have performance issues about the data serialization. It's very expensive. And here we provide solutions like like SQL interface. See, we provide exist, transform, filter, reduce. It can this operation can directly on the complex object. For example, the first one, it will help you to check the whole array to see whether there is any elements satisfy this condition. And it also can do the map, transform from one array to another array using the function you specify. And here is filter out some illegal array elements. And the last example is just to do the sum. You don't do any aggregation. Okay, so for more details, you can check the Databricks blog, and there are more cool features available in the Databricks Runtime 3.0. We might, in the future release, we will contribute back to the open source. So the load phase. In the different writer APIs, previously, you only can create the data source tables. Right side is the example how to create a package data source, but this is Spark data source tables. It does not allow you to create a Hive 30 tables. Now, in 2.2, we provide this. After we unify the write path, you can create a Hive 30 table. You just need to specify file format. We also unify the SQL interface. Here, previously, the left side, see, the create table starts as the ORC. So this allows you to create a Hive 30 table, Hive ORC 30 table. And after unification, we allow you to do something like create a table using Hive and put a file format ORC here. And the right side is the same, no change. Okay. After unification, so this is our preferred syntax to create a table. We unify them together. Maybe nobody knows what's the difference between the Hive 30 table and the data source tables. But now, after we unify, it may be easier for you to use it. Okay. Actually, in the 2.2, we did a lot of efforts to improve the ETL pipeline. And we plan to add more features in the future releases. Here, I just want to emphasize some very cool features we want to do. Before, maybe 2 years ago, we published the first generation data source API. But we got some feedbacks, and then we plan to define the next version of our data source API. The first target is to improve the performance. So, like serialization, deserialization is very expensive. How to solve the problem? So we plan to publish the column binary format. Then we don't need actual serialization and deserialization. We also avoid conversion to and from RDD row. So this is the internal, our only public format. And we also continue to support for the filter pushdown and the column pruning. But we might also add more pushdown capability, like limit, sampling, and so on. So the Python UDF, in the previous talk, so it shows some ideas how to do it using arrow. Here we also have a little bit different plans. So after we publish our public format, it will also benefit the Python UDF. It will improve the data exchange efficiency between the Python and the JVM. It avoids unnecessary serialization, deserialization. And Python is used a lot in the ETL pipeline, so I think we have to improve it. And we also plan to provide a new UDF interface. We call it a block level UDF. You can pass the block-based arguments and return the block-based block. So this talk, I will cover what is ETL pipeline, and why it is hard, and how to use Spark SQL to solve these ETL problems, and explain some new features, some existing features to solve the ETL issues, and also mention how we unify the write path in the 2.2 release, and also fix many issues, bugs about this. And in the future, we plan to improve the performance, and you can check the Jira and to see what we will do in the new version of data source API. And yeah. So maybe you can try the David's. So we provide unified analytics platform. So especially runtime 3.0, the performance is very good. It has optimized for the cloud, and the caching on the optimized layer, DBIO, was added. And we also have a security guarantee. So any question about the ETL?
Thank you, Xiao.
Thank you.
We got mics on 2 sides of the aisle. If you have any questions, feel free to come up. We got some time left.
Hi there, I had a question. Can you hear me okay?
Yeah.
It's a bit louder.
Can you hear me now?
Yeah, better.
Yeah, so did you do any work where the disparate schemas, once you've written to disk into like a Parquet file or hard table, how to handle that?
The Parquet file?
Yeah, with schema mismatch, once you've already written to disk.
I think we don't allow that, but you can change. In the 2.2, we provide, we add a new DDR. You can add a column to the existing schema. But in the future, we plan to allow user to drop the column from existing schema. Another choice, you can create external tables, and again, using your location of your files. Thank you.
Any other question? Give a big hand to Xiao. We're going to have his office hours tomorrow at 3:40, so stop by the booth. Thank you.